Hello and welcome to Learn Data. It's great to have you on this channel. Today we are going to continue learning about pandas, and in this concluding video on visualizations we'll look at some formatting and other issues that we can use pandas tools to create visualizations. Specifically, we'll be looking at how to change the style of lines, how to convert axis to logarithmic axis, how to use a secondary y-axis, how to make a compact x-axis, and then how we can go ahead and create subplots as we saw in one of the previous videos in Matplotlib. Additionally, we'll look at how to create error bars and how to add tables to plots as well. So let's get into Jupyter Notebook and start coding. Here I've already created a new notebook and imported three libraries: NumPy, Pandas, and Matplotlib. And for data, we are going to use the same data set that we have been using in past two videos, which is the flowers data set. So let's go ahead and create our first plot. Sorry, I'm gonna create some new lines here. Okay. So the first plot we are going to create is using the same way that we have seen earlier, plt.figure, and then here we are going to use flowers. And when in the flowers, we'll use just one column, which is the num orders, and we'll use the cum sum just to make the plot more interesting. Let's show plot without the cumulative sum and see how the plot looks, and then we can probably go ahead and change that. Now here we are adding a new argument, which is style. So style, here we can specify how we want the plot to look like. So let's go ahead and plot this first. So this is not as interesting, so I'm going to add cumulative sum here so we can see some trend going on. Now in this plot, what we are going to do is add the style. So when we add style is equal to, let's say color is green and we want dash and dot. So when we add this, we can see that the plot is now changed to this dotted plot where there are dots and lines together. So that there are other variations of this style that we can use. For example, instead of this, we could simply use the dot. That also works this way. Then we can use dash dash and the plot looks like this. Then we can go ahead and use maybe a plus sign and the plot looks like this. Then we can also use dash O and the plot looks like this. And here if we set alpha, so alpha is equal to 0.5, then or maybe 0.15, then we can see the spaced out points a little bit. So that was one way to create the plots as we see here. Now in this case, if you notice, what we have is explicit series, which is specified by one square bracket. For example, if we go ahead and look at the type of this, we see that it's a series. Now if we put two square brackets around it, we can see that it becomes a data frame. So in this particular plot, let's use a data frame, and now when we plot this, we can see that we get an legend. So if we need that legend, then we can use this. However, if we want to remove this legend, what we can do is specify here that legend is equal to false. So when we specify legend is equal to false, we can go ahead and remove the legend from the plot, as we can see here. Next, let's look at how we can create axis that is logarithmic. So for creating a logarithmic axis, we need to pass one keyword argument that I'll show. So let's go ahead and do that. Now flowers will use the same series num underscore orders, and here we'll use the cumulative sum just to make the data more interesting to plot. And for plot we'll supply the style. Actually it's not needed, it's optional, but we can give it a style. And then for the logarithmic we are going to say log y is equal to true. What that will do is when we plot this, the axis for the y is changed to logarithmic, as we see here in the above plot above. This is a linear scale, however here we can see that the scale has now changed to a logarithmic scale. So that's the difference there. Now let's see how we can add a secondary axis. For this, first what we are going to do is create a new smaller data frame, which is temp is equal to flowers, and here we are going to use the column num orders, and we are going to create a copy of this, so we keep the original data frame intact. And then we are going to add another column num orders 2 to this temporary data frame, which is the same numbers as num orders, except that we are going to multiply it by 10. So that's our new data frame that we are going to use for plotting. Now we want the num orders to be on the left y-axis and num orders 2 to be on the right y-axis. To do that, what we'll do is type x is equal to temp dot cumsum, and we are using cumsum because to make the data look visually more trendy, I guess. And then we'll plot, and secondary underscore y is equal to num underscore orders 2. So that's where we want to specify that this column needs to be plotted on the secondary y-axis. Now here we can see that we have the column second data set, which is the column num orders 2 plotted on the secondary y-axis. However, we do not see the first num order, so let's see why. If we go ahead and change this and make this maybe into -10 and run this again, okay, so the data was overlapping and therefore we are not able to see it. So now we can see that there are two distinct data sets, and the negative axis we can see it is on the right hand side. What we can do next is add labels to this. So ax.set underscore y label, and we can add labels to both the left and right axis. So for left axis this would be the left scale right here, and if we want to add the label to the right side of axis, so we can write ax.right underscore ax, and then set underscore y label, and here we can specify this is the right scale. So now when we look at the axis, we see that we have the labels for both the primary y-axis and the secondary y-axis. And here interesting thing to note is in the legends we can see that within parentheses for num orders 2 it says right, and that indicates that to look at this data we want to refer to the axis that's on the right hand side. We can go ahead and remove the word right that's in the legend, and to do that what we want to type in the plot command is mark underscore right is equal to false. And when we do that, the words in the parentheses right are removed from the legend, and now we just have num orders and num orders 2 as two series plotted here. So that was how we can change the or we can plot the data on the secondary y-axis in addition to the primary y-axis. Next, let's look at how we can format x-axis. And what we are going to do in here is as we see in this x-axis above, we have the ticks arranged in a different way, where it says Jan 2019, then July, and then again Jan 2020. We can change that and make the y-axis look more compact as well. So for that we'll use the flowers dataset, and we'll use the num underscore orders again, and again we'll use the cum sum. Now in the plot what we want to specify is x underscore compat without the c is equal to true. When we specify that, here we can see that now the x-axis is arranged differently, and we have more labels to the ticks that are on the x-axis. Next, let's look at how we can apply this formatting to multiple plots. And to do that, we are going to create a new figure here, figure, and we are going to type with pd.plotting.plot underscore params dot use, and within here we are going to specify x underscore compat colon true comma true, and then we are going to specify the commands for plotting. So flowers and num underscore orders dot cum sum and then plot. So I'm gonna go ahead and copy this entire line here and paste it a couple of times, so we have multiple lines in the plot. And these data set, to make them appear differently, I'm going to divide them by 2, then divide this one by 3, and divide the last one by 4, so that we can see distinct data sets, distinct lines when we create the plot. And for this we can go ahead and give this different colors so that again we can distinguish them. So maybe it's red, green, and maybe black color right here. Now when we run this, we can see that all the lines are plotted in the same plot, and we have changed the x-axis formatting for all these 4 plots in one setting. So that's how we can apply formatting to multiple plots in multiple data plots in one plot, as we can see here. Next, let's look at how we can create subplots. And for creating subplots, we have seen this in how we create it in matplotlib. Here we'll use a data frame to directly create subplots. So flowers dot plot, and when we say subplots is equal to true, and we give the figure size, so fig size is equal to, let's say, a tuple of 7 by 7. When we run this, we can see that automatically it should create 4 subplots for all the columns that are in the data frame that are numeric. And here we can see that the column prod, summer, winter, fall, spring, and num orders are there, and all of them are now plotted here as subplots. Now let's look at another way in which we can create subplot. So here we have flowers.plot subplots is equal to true, and layout is equal to, we are going to supply a tuple of 2 by 3, and fig size is equal to 7 by 7, so that's just the size we have, and sharex is equal to true. And as we can see here, we it should create 2 by 3 subplots. So this is another way in which we can create subplots, as we see. Yet another subplot method we can use, and for this we are going to create positions. So let's go ahead and work with this. So figure ax is equal to plt dot subplots, and we are going to use a grid of 5 rows and 5 columns. So we are specifying that here, and then we have fig size is equal to, let's use a 10 by 10 grid, and now we'll specify position 1 and position underscore 2. So both these would be a list of positions by index of the grid. So at 0, index 0 0, that the leftmost top corner, we are going to specify 0 0. Then we have the right corner in the top line, which is going to be 0 and 4, and then the bottom corner on the left is going to be 4 comma 0, and then the bottom corner on the right is going to be ax 4 comma 4, and then we'll use another position, let's say 4 comma 3. Next, let's put positions for 2, and there's ax have 1 1 1, so we'll go diagonally in this case. Ax 1 1, ax 2 2, then we have ax 3 3. We have already used x4, so I'm gonna use ax2 4, and another position we can put here is x3 comma 1. So these are the positions we will be using, and now we can use those in this plot. So flash.plot subplots is equal to true, and then we are going to pass x as position underscore 1, and then share x is equal to false, share y is equal to false. Similarly, we for the second positions, which is the position 2, I'm going to use the same stuff and add position 2 right here. Now when we go ahead and plot this, we have an error flowers, so this should be flowers instead of flowers, so that's my mistake. Now when we run this, we can see that we should get a plot that is 5 by 5, and the data plotted in the grids that we specified. So as we can see, we do have the 4 corners, we have data plotted in all those, and then we have diagonally we have these data points for position 2. So that's another way in which we can use subplots to create plots and specify them in the specific position within the grid as needed. Next, let's look at how we can use error bars to how we can add error bars to bar plot. So error bars, especially if you are working with sometimes experimental data, I've always used the error bars when plotting them. So these could be standard deviation error bars that could be used. So to use that, we are going to create a new data set, which is a flowers underscore mean, and the reason why we need this new data set is because we are going to plot means and their standard deviation. So for means, we have flowers dot group by, and we are going to group by on species. So for species, we have group by species, and then we are going to get the mean for this and put that in the data frame flowers underscore mean, and then we are going to create another data frame flowers underscore std where we are going to put the standard deviation. So now we have these data frames ready. We can take a look at them. Flowers and flowers underscore mean, this is how the data frame looks. The index is species, and then we have flowers underscore std, which shows the standard deviation. Now we can use this data frame to create the plot. So flowers underscore mean dot plot dot bar, so this is going to create our usual bar plot. Now if you want to add the error bars to this y-axis error bars, you can also go ahead and add x-axis if you need to, but here we are going to add the y-axis error bars, and we are going to specify the flowers underscore std data frame for that. And when we run this, we do get error bars as we can see here, but now they do not have the caps on the top and bottom. Caps are those horizontal lines. So I'm going to add that by specifying the cap size is equal to 3, and now you can see that we have added really nice error bars that are specific to each of those bars in the data set for each of the species. So that's how we can go ahead and add error bars to a data set when we are doing the plot. Now moving on, let's look at how we can add tables to a plot. And to add tables, what we can do is create tables can be added at various locations. We'll look at that. So let's go ahead and create first figure with tables. So plt dot subplots, we are going to use just one position there, so 1 1. X dot get underscore axis, and here we are going to set the x-axis to visibility of the x-axis to false, so that it does not overlap with the table that we are going to put in place of the x-axis. So that's the reason why we have that. So set underscore visible, and this is false. Now what we are going to do is specify flowers underscore mean dot ilog. So we are not going to use the entire table this time, so we'll just use the first 3 rows and the second column from there, dot round, and we are going to do the rounding just so that there are not too many decimal places to plot. And here we are going to specify table is equal to true, ax is equal to ax, and run this. So here we now have a plot where in the x-axis we have the table. So each data point, so this data point is for Elysium, and then the last data point is for Aster, and we have the production numbers for fall season that are plotted and also listed in the table below. So that's one way in which we can create a table with the plot. The next we'll look at another way in which we can create a table. Here we are going to create another plot. So figure ax is equal to plt dot subplots, and again we are going to use 1 because we just have one plot. And here before we move forward, I just want to show you that if we set this particular line, we remove that line, what happens is we get this overlapping where the axis overlaps with the table, and therefore it's important to put that in there to remove that x-axis, and we have this plot set up right here. I'm sure there is a way in which we can have both axes as well as the plot, the table. So I'm going to put here ax underscore get x-axis, and then we are going to set its visibility to false so that it does not overlap with the table that we are going to plot below the plot that we are going to create now. So flowers underscore mean is the same table we are going to use. And just to show you, I'm not going to do the rounding for this, and I'll show you later why. So table is equal to we are going to use the table flowers underscore mean, and I'm going to transpose it so that it aligns with the plot that we are creating. And then after that, so transpose, okay, so we don't need that, sorry. And after transposing, we are going to add x is equal to x, and marker, I'm going to change this marker to a plus sign as we see here. Now when we go ahead and plot this, flowers underscore mean, and when axis x is equal to x. Okay, so now we can see that we have successfully created the plot. However, we cannot see anything that's in the table, and that's the reason why for the mean we are going to round this off. So I'm going to say round to 2 decimals, and in addition to that, I'm also going to go ahead and round this table that we are going to plot below. So this particular line that we are transposing, I'm going to set that to np.round and set that to 2 decimals only. So after this, when we plot, we can see that it is still font size. So you can also go ahead and change the font size as needed, but we can definitely see that all these species are listed here. For example, the top one is production for spring, and we can see that the numbers for production for spring are in above 800, and those are the plots we see there which are above 800. So that's how we can go ahead and create the plot with table for a data set. Now moving on, we'll look at one last way in which we can create a plot that can be added within inside this canvas of the plot, so inside this square of the plot area. And to do that, we need to import a library, and that's from pandas.plotting import table. So we are going to import this library, and I'm going to go ahead and create a new cells here. Now we can go ahead and create the figure. Fig comma x is equal to plt.subplots, and we'll just use one position from that, and for table we'll specify table, and then in open close parenthesis we'll specify x, and flowers underscore mean dot ilog, and here we'll just use 3 rows and from just one column. And after this we need to specify the location for the table that we are going to put in the plot. So let's put it at lower right corner, and column width is equal to let's say 0.2 will be the column width. If there are more than one columns that we need to put there, then it will be multiples of that. So here we just have one column, so I'm going to multiply by 1. It's not needed, but just in case. So flowers underscore mean dot ilog, and here we are going to use the same data 3 and 2 dot round, just so that we round it to 2 decimal places. Plot x is equal to x, and once we have this, we can now go ahead and plot the data. Now because this is more lot of numbers there, we can change that by putting this particular part of the table into np.round, and here we can specify just 2 decimals, and now we can clearly see the data and read it. So here we have thus created a new way of adding a table to an existing plot. Finally, let's look at how we can use color maps. And these color maps are those that are already inbuilt in matplotlib. So the easiest way is to use this flowers dot plot, and we can specify color map is equal to any specific. I've looked up on the site, and there's plasma, which is one type of color map, and here we can therefore see the grade variation in the grades of the color for each of the line that we have plotted here in this particular plot. Next, we can also look at another method in which we can use the color maps directly from the matplotlib, and for that we need to import from matplotlib. So from matplotlib we are going to import cm, and cm is the library that we will be using. So matplotlib cm is the library that we will be using to create the plot. So flowers dot plot, and here we are going to specify color map is equal to cm dot plasma. So when we type that, we again get the same plot that we had above, except that we have used a different color map to create the plot. Again, you can change the settings for legend and move it outside. Again, there is another color map, say winter, and you can get different types of variation in the colors that you can use for plotting your data. So that was it for this video. I hope you all learned how to format the plots, how to format x-axis, y-axis, how to change the axis to secondary axis, how to change colors, how to create tables that could either go near the x-axis or they could be put inside of the plots, and how you can change the design of the line that is plotted, make it a dotted line or add different markers to the same line. In next video we'll continue learning more about pandas, and I'm hoping you learn these techniques from pandas visualizations library to in your own work and your own projects to visualize data. Please like, share and subscribe. It helps me create more interesting content for you all. I'll see you all in the next video. Thank you.